Hi guys, this is Dr. J here, and in this video we are going to continue our discussion on oxidation reduction reactions. Please note that there is another video before this one which basically discuss a lot of details on oxidation reduction reactions. And just to summarize what we learned in that video, we learned what are oxidation reduction reactions. So basically oxidation reduction reactions are a very common group of reactions that can be seen in chemistry. So in these reactions, reactants exchange electrons between each other, and therefore certain reactants could lose electrons and certain reactants could gain those electrons, and therefore there is always an oxidation and a reduction going on in oxidation reduction reactions. Just for the record, oxidation couldn't survive without reduction. So in reactions, in chemical reactions, both oxidation and reduction has to happen simultaneously. Okay, so basically in oxidation there is a loss of electrons, and in reduction there is a gain of electrons. So in regular general chemical reactions we don't always focus on the loss or gain of electrons, so therefore it might not be easy to track these electrons as is. So therefore, in order to get rid of this issue, we use something called oxidation number. Okay, so every atom involved in a chemical reaction has this concept called oxidation number. So this is basically very similar to a charge of an atom. Okay, so every atom has this oxidation number, and by tracking what happens to this number, you can basically predict oxidation and reduction. So basically during oxidation there is an increase in oxidation number of a particular atom, and during reduction there is a decrease in oxidation number. Okay, so keep that in mind when you're looking at oxidation reduction reactions. So the next important thing to understand in oxidation reduction reactions is oxidation number, because oxidation number helps us to identify oxidation and identify reduction, and also this oxidation number can be used to balance the chemical reaction. So in the previous video I basically discussed the first eight reactions, first eight, not reactions, first eight rules for calculating oxidation numbers of different atoms. Okay, and today we are going to focus on the last two rules. Okay, number 9 and number 10 rules for the oxidation numbers. Just to remind you what we learned in previous video, or just to remind you the first eight oxidation number rules. Okay, so if you have a neutral atom or a simple molecule where you only have one type of atoms, okay, the oxidation number tend to be 0 for that atom. Okay, and according to rule number 2, if you have simple ions, the oxidation number is equal to the ion. Okay, and in rule number 3 and 4 we discuss the oxidation number of hydrogen, and the oxidation number of hydrogen is +1 if hydrogen is attached to a non-metal, and if the hydrogen is attached to a metal, the oxidation number of hydrogen is going to be a -1. It is going to be a -1. Rule number 5 and 6 talks about group 1A and group 2A metals, group 1A and group 2A metals. And according to rule number 5, when there is a group 1A metal involved in a chemical compound, the oxidation number of that group 1A metal is always a +1. And as you know, group 1A metals only make +1 charges. That is why this rule tells you that the oxidation number of group 1A metals is a +1. And according to rule number 6, group 2A metals containing compounds always tend to have a +2 oxidation number for the group 2A metal. Okay, so if you have a group 2A metal in a chemical compound, you can close your eyes and then say, okay, the oxidation number of the group 2A metal is a +2. And similar to these two, you can also predict the oxidation number of aluminium. Okay, you can also predict the oxidation number of aluminium. Why? Because aluminium always make a +3 charge. If you remember, aluminium always tend to make a plus 3 charge in a chemical compound. So even though it is not a rule or it is not listed in here, usually when aluminium is present in a chemical compound, the oxidation number of aluminium tend to be plus 3. It tends to be plus 3. That is something you might want to remember, even though it is not written in these 10 rules. Okay, and rule number 7 talks about oxidation number of oxygen, which is usually a minus 2. But there are exceptions, and peroxides and superoxide are those exceptions. Oxygens in peroxides have an oxidation number of minus 1, and oxidation number of superoxides or oxygen that is present in superoxide compounds have an oxidation number of minus half for oxygen. Rule number 8 talks about halides, usually halide compounds. In halide compounds, halogen atom has a minus 1 oxidation charge. Okay, halogen atoms have a minus 1 oxidation number for halogens. And rule number 9 and 10 is basically a way to use all the other 8 rules that we discussed to calculate the oxidation number of any other atoms or unknown atoms. Okay, so I think in previous video I did a couple of examples, but I'm going to start discussing rule number 9 and 10 in detail in this video. Okay, and in rule number 9, it says that the sum of oxidation numbers in a neutral compound is 0. So let's take a notepad and then we will try to practice this rule. Okay, once again, according to rule number 9, the sum of oxidation numbers in a neutral compound is 0. So let's take a neutral compound. Let's take a neutral compound like NO2. Okay, so the compound that I'm going to take today is NO2. NO2, and we have to calculate, let's say, the oxidation number of nitrogen, because the oxidation number of nitrogen was not covered in the previous 8 rules, and therefore we have to calculate the oxidation number of nitrogen. So this is the unknown oxidation number. This is the unknown oxidation number. Okay, and of course you already know the oxidation number of oxygen. Okay, oxygen atoms have a minus 2. Usually the oxidation number of oxygen is minus 2. Okay, and then actually in this formula you have one nitrogen atom, and then 2 oxygen atoms. So if you add the oxidation number of that nitrogen and the 2 oxygen atoms, the sum of oxidation numbers should be a 0. Okay, should be 0. So oxygen is minus 2, so it is 2 times minus 2, which will be minus 4. And then you have nitrogen oxidation number, which we don't know yet. Okay, equals 0. So when minus 4 goes to the other side, it will become a plus 4. So nitrogen oxidation number is actually plus 4. Plus 4. So this is how you use the rule number 9. Okay, in a neutral compound, the key here is that the compound has to be neutral. Okay, in a neutral compound, the oxidation number sum is equal to 0. So let's take another example. Now I'm going to use let's say MnO, manganese oxide. Okay, manganese oxide. All right, so do we already know the oxidation number of manganese? No, we don't know that, but we know the oxidation number of oxygen, which is minus 2 from rule number 7. Okay, and then we have to figure out the oxidation number of manganese. Okay, we have to figure out the oxidation number of manganese. This is the one that we don't know, or you can treat it as X. Let's call it X. Okay, let's call it X. So the sum of oxidation numbers, which is X plus minus 2, is 0. So when minus 2 goes to the other side, it becomes plus 2. So X, the oxidation number of manganese, is actually what? Plus 2. Okay, so the oxidation number of manganese becomes plus 2. So as you can see in this example, okay, the sum of oxidation numbers should be add up to 0, okay, should add up to 0. So as you can see in the oxygen side you have a -2, in the manganese side you have a +2. So the sum is 0. +2 plus -2 is 0. So let's take a few more examples. Let's take a few more examples. Let's take sulfur trioxide, SO3, as an example. Okay, let's try to calculate the oxidation number of this compound. Okay, so you have oxygen in here. Oxygen is usually -2. And how many oxygens you have? You have 3 oxygens. You have 3 oxygens. So that will be a -6 in this side, just like you calculated the charges. Okay, so in this side you have a total of -6 from the oxidation number. Remember, each oxygen is a -2. Okay, so sulfur should bring +6 to the table. Sulfur should bring +6 to the table. So therefore, the oxidation number of sulfur is +6. So the oxidation number of sulfur is +6. Okay, let's do some more examples. Of course, let's try something like let's try P2O5. P2O5. Okay, phosphorus pentoxide, diphosphorus pentoxide. Okay, let's try this one. Let's separate the two atoms so that we know we can do it easily without writing equations. For each oxygen, the oxidation number is -2. All right, and then you have 5 oxygens. So oxygen side has a grand total of -10. So two phosphorus should give you a +10. Should give you a +10. Okay, so the oxidation number of phosphorus should be 10 divided by 2. Why? You have 2 +10 coming from what? +10 coming from 2 phosphorus. So 1 phosphorus should be half of that. So phosphorus oxidation number is 10 divided by 2, or you can write it as +5. +5. Get it? So let's do some more examples. I mean, practice makes you perfect. Okay, so you will have to keep on doing them. Okay, keep on doing them. So let's do carbonic acid, HCO3. All right, so you have to figure out the oxidation number of, let's say, carbon. Okay, that is the unknown thing. You have to figure out the oxidation number of carbon. So to do that, you will try to use the oxidation numbers of hydrogen and oxygen for each. So this is our unknown. Let's call it X. Okay, so we already know the oxidation number of oxygen, which is -2 from rule number 7. And then hydrogen is bound to a non-metal. So according to rule number 3, the oxidation number of hydrogen is what? It's +1. +1. So the 3 oxygens is a -6. The 3 oxygens, I'm trying to use different colors so that you will not be confused. So I'm going to separate carbon, hydrogen, and oxygen. So hydrogen will bring +1 to the table. 3 oxygens will bring what? Actually, I made a small mistake. Okay, this formula should be H2CO3. Okay, H2CO3. I made a small mistake. So you have 2. I mean, it's okay. So you have 2 hydrogens. So hydrogen brings +2 to the table. Okay, it brings +2 to the table. So this should be +2. Okay, and you have 3 oxygens. -2 times 3, it is a -6. Okay, to balance everything out and make the whole thing 0, carbon should be what? Carbon should be +4. Carbon should be +4. That is the only way you can make the whole thing 0. The sum of oxidation numbers 0. So carbon should be a +4. A +4. Okay. Let's do another example. let's do NCl3. NCl3. Okay. So in here, you have to figure out the oxidation number of, let's say, nitrogen. Okay, this is what we need. This is what we need. We already know the chloride oxidation number. It is -1. It is -1, and you have 3 chlorides. So chlorine gives you a -3. So you have 3 chlorides, so it gives you a -3. So to balance that, nitrogen should be how much? Nitrogen should be +3. So the oxidation number of nitrogen right here is a +3. Okay. All right, so I hope that you understood what we did here. So what I'm going to do is I'm going to give you a bunch of different examples right here, and you will pause the video and then see if you could solve them. Okay, see if you could solve them. Okay, so I'm going to start with, let's say, I'm going to start with simple ones. Okay, it's number 1. You can try to do them as soon as possible. Okay, so the oxidation number that I want is carbon oxidation number. And you can start. Then let's do All right, let's try these 6 oxidation numbers. I mean, I'm going to write the answers so you can check your answers. If you are still working, you can pause the video now and then try it by yourself and then compare your answers, okay? For carbon, the oxidation number is +2. Then this will be +1. For nitrogen, each nitrogen is a +1. The 2 nitrogens are +2, of course, okay? So when I'm putting the oxidation number, I'm putting the oxidation number of 1 atom, okay? 1 atom of nitrogen. Of course, you understood it by now, right? All right, let's do a few more examples. I'll start with something like this. Let's try some oxy acids, okay? All right, let's see if you could do them. Okay, if you haven't done it yet, you might want to pause the video and try it by yourself. Okay, I'm going to write the answers now, okay? All right. So if you are not done, just pause the video and try it by yourself, okay? Just for the record, the oxidation number of oxygen is -1. Okay, actually, I pointed the wrong atom. I wanted you to calculate the oxidation number of oxygen. So you should know potassium oxidation number, which is +1. It is always +1. Remember, it is a rule. It is rule number 5. Okay, so this is an obvious one. This is an obvious one. Why? Because this is rule 5. So the atom that has a different oxidation number or a ambiguous oxidation number should be oxygen. Okay, this is the tricky atom. So you use the potassium oxidation number. You have 2 potassiums, so it should be +2. Okay, potassiums will be +2, and the 2 oxygens should be -2 to make everything 0, right? So each oxygen is what? Each oxygen is a -1. Is a -1. All right, let's do a few more. We want to continue what we started, right? So let's do this. All right, let's try them. So for chlorine, it will be +5. Let me use a different color. This chlorine is a +1. This bromine is a +7. The manganese is +6. I mean, if you feel like scratching the head right now, this is how you do it. 1 oxygen is -2. So the 4 oxygens is going to be what? -8. 2 sodiums are going to be +2. Each sodium is a +1 from rule number 5. Okay, so manganese should balance everything out. Okay, so in here, let me change something. All right, so in here, 4 oxygens again -8. 2 sodiums is +2. So the sulfur should be what? +6. Sulfur is +4. All right, let's do these 3 really quickly. Oops. Oh, sorry about that. So let's do this. Let me change the color. Let me use blue color. Okay. This could be tricky, okay? Take your time. Take your time for this one. All right. If you're not done, you might want to pause the video and try them. So I'm going to do it right now, okay? So pause the video and try them first before looking at the answers, okay? You have 3 oxygens, that is a -6. 2 sodiums +2. So the 2 sulfurs should be what? +4. Okay? Should be +4. So the oxidation number of sulfur should be what? The oxidation number of sulfur should be a +2. Okay, so in here, you have 6 oxygens, that is -12. 2 sodiums +2. So the 4 sulfur should be what? +10. Okay, things are good, but then you have to divide it by 4 to get the oxidation number of each sulfur. So it will be equal to what? Plus 2.5. 2.5. Okay, and in here potassium oxidation number is a +1, so the two oxygens should be what? A -1. So the oxidation number of one oxygen is -half. -half. Okay, now I think you can handle it. Okay, you can handle it. So see if you could do this one again. Let's say K2 CrO4 and then K2 Cr2O7, potassium chromate and potassium dichromate. Find the oxidation number of chromium. Okay, so pause the video now and then see if you could do it. All right, the 4 oxygens is -8, 2 potassiums +2, so chromium should be what? +6. If you do the same thing for this one, this will also be +6. Okay, all right, with that I'm going to go back to go to rule number 10. I hope that rule number 9 is very clear to you. Okay, so according to rule number 9, the sum of oxidation numbers of a chemical compound, of a neutral chemical compound, is equal to 0. Okay, is equal to 0. That is rule number 9. So let's go to rule number 10 next time. All right.